Hello, is it audible? Okay. Hello. Am I audible, visible to you? Could you please confirm? Okay. Thank you. So, from which college you are presently? Okay. Don Bosco College of Agriculture. Where is it? Tamil Nadu. Okay. Okay. So, right now you must be doing BTech, I think. Is it so that you are doing BTech or any other program? I'm just asking. Okay. BSc in Agriculture. Great. Great. BSc Honors in Agriculture. Okay. Great. We shall wait just for 3 minutes, then we'll start. After 3:05, I'll start. Yes. Okay, we shall start. Let others join in between. Okay, good afternoon, everyone. My name is Ambuj. I am a research scholar at Agriculture and Food Engineering Department, IIT Kharagpur, and I'll be taking your live interactive session for the course Farm Machinery. This course is taught by Professor V.K. Tiwari, Director, IIT Kharagpur. And what we'll be doing in this particular session, that I'll be posting some of the questions based on the previous week's content. Okay, these are objective questions, and what you have to do is you have to just give your opinion about the question in the chat box or in the messages section. Okay, and after the question I'll give you the entire explanation, as well as I'll delve deep into the concepts also. Okay, so the very first question for today is this one. Okay, the vertical distance from the upper linchpin to lower linchpin in 3 point hedge system is known as upper hedge point, lower hedge point, upper hedge height, lower hitch height, mast height, or lynch height. Okay, just try to give your opinion in the comment section. Thereby, you can recall also the previous week's content. Okay, thereby we'll be having discussion. Please do try to solve this. Okay, vertical distance from the upper linchpin to lower linchpin in a 3-point hitch system. What is it known as? Okay, do try to give answer. Yes, what happened? Nobody responding. What happened? Mast height. Great. Great mast height. Okay. Let others give their opinion also. Two more people are there. Please do give your opinion. Need not to be it is correct. Okay. Don't fear that it has to be correct or something. Yes, yes. Yella Swami, if you want to say anything, please go ahead. Okay. Don't fear. Okay. Have no fears. Just try to give your opinion. Okay. It need not to be correct.
Okay.
Okay.
Mast height.
Match height. Okay, great. So please do type in. Okay, because a lot of people are there, so might be some noise is there from your side. Okay, I'll just write here. Yella Swami is saying match height. Okay. You can just mute yourself. Okay. Yes. Noise might be there from your side. That is why I was saying. Okay. Okay. Great. Match height. One new person has also joined, so I like to have his opinion also. Please do give your opinion about this question in the chat box. Okay, need not to be it is correct in the very first attempt. You just try to answer this particular question. It is based on the previous week's content. Then we'll go for the explanation. Okay. Yes. Okay. So the whomsoever have answered, they have answered it correctly. Okay, the vertical distance from the upper linchpin to lower linchpin in 3-point hitch system is known as mast height. Okay, see here, this is the tractor hitch system. Okay, just try to look at the figure in on the left hand side. Okay, all the parts of a 3-point hitch system or 3-point hitch hydraulic system is shown in the figure on the left side. Okay, A, see here, just see, I'll point out whichever part I am saying about. Okay, I'll just point out. Okay, A, this component is known as the upper link of the 3-point hitch system. Okay, B and C are the draft arms. Okay, why they are known as draft arms? Because as you already know, draft is the horizontal component of pull. Okay, so they just uh, try to pull the implement in the horizontal direction. That is why they are known as draft arms. Okay, and D, as you can see here, this is anti-sway bar or chain. It tries to localize the system, or it tries to keep the system at the same point, same position in case some undulations are there. Okay, so the implement sway or the movement along the uh, y-axis is restrained using these anti-sway bar or chain. Okay, then E, that component is your lift arm. Okay, just see here, this one is known as lift arm. Okay, and F is your lift rod. This is a typical 3-point hitch system of a tractor. Okay, yes. So three options were given, and D was, I think, lynch height. Lynch height is not a valid term in case of hydraulic system, so we will directly eliminate this one. Okay, this one we can eliminate. I'll just mark it red. Okay, this we can eliminate. The three most important distances were upper hitch height, lower hitch height, and mast height. Okay, uh, particular terms were there. Okay, upper hitch height means vertical distance from the ground to the upper hitch point. Okay, upper hitch point I already showed you in the previous figure where it is. Okay, so upper hitch height means the vertical distance from the ground to the upper hitch point or the upper linchpin. Okay, uh, in this particular hole a pin is inserted which is having a key. Okay, so that the load gets transferred up to a certain limit onto the tractor. Okay, that is known as linchpin. Design of linchpin is done in machine design course. Okay, so whatever the forces which would be coming on the linchpin, they will be dealt, and certain factor of safety is also kept. Okay. After that, the pin should break. Okay. If the draft or the pull on the tractor or on the 3-point hitch system increases drastically, then it should break. Okay. The tractor should be safe. That is why design of linchpin is important. Okay. So this is linchpin. Okay. So vertical distance from the ground to the upper hitch point is known as upper hitch height. Okay. Another term was lower hitch height. Okay. Vertical distance, similar, same definition is there, but in place of upper hitch point, there will be lower hitch point. Okay. Vertical distance from the ground to the lower hitch point or the lower linchpin. This one. Just a second. This one is upper. Okay. And this one is lower. Okay. So this one is your lower hitch height. Okay. And another term was mast height. Okay. Vertical distance from the upper linchpin to the lower linchpin. That is known as mast height. Okay. Three particular terms were there. I have explained all of them to you. Okay. Linch height is not a valid term in case of 3-point hitch system of a tractor. Okay. Are these terms clear? Is this question clear? Clear, not clear? Any doubt? Then please do ask me. Okay, if it is clear, then please say me. I'll move forward. Clear? Okay. Yes, Hari Krishnan wants to answer something. Yes, please do ask me. Yes, Hari Krishnan, HK. Please do ask me. If you want, if you are having any doubt, then please do ask me. I'll be happy to explain. Lynch height. Okay, okay. Yes, Swami, your query also. Please do ask me.
What is the difference between the hitch and hitch pin and linchpin?
Both are same. Hitch pin
Both.
is also known as lynch pin. Okay, it's a kind of
Okay,
pin. You will be seeing this in your practical classes. Okay, they'll just put a pin which is having a key. Okay, it is designed in such a manner that if the draft or the load on the tractor hydraulic system it increases to a certain level, then it should break. Okay, as I already told you, both are the same thing. Okay, yes. Now Hari Krishnan's question, lynch height. Okay, I'll just explain you. Just forget about lynch or the if some confusion is there, just keep in your mind hitch height. Okay, hitch height, upper hitch height, lower hitch height, and mast height. Three different types of height are there. Okay, upper hitch height is the vertical distance from the ground to the upper hitch point. Okay, this one, this arrow which I have marked here, just aside F. Okay, it is there. This from this arrow to the ground, that is my upper hitch height. Okay, then lower hitch height, vertical distance from the ground to the lower hitch point. Okay, that one is my lower hitch height. See the arrow aside C point I have marked. Okay, this from this arrow to the ground, that one is your this one, lower hitch height. Okay, another one was mast height, vertical distance from the upper linchpin to the lower linchpin. The vertical distance from these two arrows, between these two arrows, that would be my mast height. Okay, now clear? Hari Krishnan, if you are still having any doubt, then please do tell me. Okay, you can unmute yourself, no problem. If it is clear, then you can tell me. Yes, if it is clear to you, then only we'll move forward. Yes, okay. Now coming to the next question. Please do try to give your opinions, need not to be you are correct. Okay. But please do attempt to solve this question. According to ASAE standards, the maximum drawer power of a 3-point hitch system with category 2 implements is given by. Straightforward question. Okay. Please do tell me what are your opinions. Okay. Okay. B. Okay. C. Great. It is already dealt in the lecture. That is why I am asking you first before telling the correct options. Okay. Don't think so that I want you to do some hard work. It is already dealt. It is a practice session. That is why I am conducting this in this manner. Okay. Somebody in the previous session was telling me that explain the question first. Okay. I'll explain each and everything at the last. But first you should attempt, because you are the students in this course. You have to give the examination. Okay. I'll not be present there telling you everything beforehand. I have read it and now I am done with it. Okay. So I am teaching. That is the thing. Yes. Yeah. 4 people have answered B, C, C, C. Okay. Great.
One second,
Yeah,
sir. I will tell.
what is your option?
Sir, B, sir.
Okay. 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 Great. Once again, I'll write it. Ella Swami says B. Okay. Great. Okay. Yes. The correct option would be C. Okay. Whomsoever answered it C, they are correct. Whomsoever answered it B, that we will see the explanation. Okay. This one table corresponds to the ASAE standards regarding the drawbar, drawbar power, and the categories in which they fall. Okay. So maximum drawbar power, just a second. Yes, it would not be HP here. Okay. Some mistake is there. It would be in kilowatt. I'll just erase it for you guys. Yes. Okay. Maximum drawer power in kilowatt. This is the distribution according to ASAE standards. Okay. Category 1. Uh, just if you see the bracketed term, that is in an HP. Okay. If you see this particular term which is outside bracket, that is in kilowatt. Okay. So category distribution is there 1, 2, 3, then 3 and 3, and they are both are same, or 4. Just try to remember. Okay, this particular sequence. Okay, category 1 means, what does category 1 correspond to? Category 1 means maximum drawer power in kilowatt is between 15 to 35, and in HP it is 20 to 45. You can just calculate it also. Okay, in category 2, the maximum drawer power in kilowatt is 30 to 75, and the bracketed term corresponds to the HP. Okay, 40 to 100. Then in third category, it is 60 to 168. And in fourth category, it is 135 to 300. Okay. This is the maximum drawbar power distribution category wise according to ASAE standard. What is the full form of ASAE? Anyone? Here it was written according to ASAE standards. What is the full form of ASAE?
American Society of Agriculture and
Yes. American Society of Agricultural Engineers. Yes. This is the full form of ASAE. This standard has been created to standardize various features which are present in automobiles, as well as they are present in tractors or agricultural machinery and implements. Okay, great. ASI means American Society of Agricultural Engineers. Yes. Okay, now we will solve this particular numerical question. First you try, then I'll tell you what is the correct approach as well as what is the correct answer. A tractor has a total weight of 134 kilonewton and a wheelbase of 3340 millimeters. If the static weight on the rear axle is 67 kilonewton, then the tractor is two-wheel drive, four-wheel drive, data insufficient, or none of these. Okay, do try to solve this. Saying option C is very easy. Okay, data insufficient. But please do keep it in mind, these are semester examinations. In this type of examinations, most of the times we will just keep these options as for the sake of keeping only. Okay, C and D won't be there. So do trust me. These are semester examinations, not a competitive examinations. So option would be somewhat between A and B. This hint already I have given you. Okay. Do try to solve it. Think about it. Take 2 minutes time. Then I'll tell you. Okay. B. Good. Four-wheel drive. Good. Great. Okay. Other people all can also try. Yes. Mercy is also saying B. Great. Four-wheel drive. Okay. Other people can also do try. Yes.
See, sir.
Yes. C. Okay. Data insufficient. Good. I already told you in semester examinations, these type of option would never be there. Yes, B. Okay. But still, if you think so, then it is fine. Why do you think so? Can you tell me? Yes, Hari Krishnan is saying B. Good. Four people have answered, and three are saying B. One is saying C. Okay, good. Any more opinions? If you want to solve, I can give you some more time. 1 minute more time I'll give you. Okay. Then we will see whether it will be A, B, C, or D. Okay. C and D cannot be an option because these are semester examinations and we have framed the question. So every present data would be there. Okay. Data insufficient wouldn't be an option. None of these wouldn't be an option. Okay. 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 Let us move forward. Yes. The correct option would be B. Why? Let us just see that. Okay. If you will see, I have given you three particular data in this question. Okay. Total weight I have given you, that is 134 kilonewton. Okay. Wheelbase I have given you 3340. Static weight on the rear axle, that is I have given you 67 kilonewton. Okay. So I have given you the weight on the rear axle, tractor rear axle as 67 kilonewton. So what will be the static weight on the front axle. Just try to calculate it and tell me. It would be 134 minus 67. Okay. So static weight on the rear axle is known, that is 134 kilonewton. Static weight on the front axle would be 67 kilonewton. So the tractor weight distribution on the front axle and rear axle is equal. The meaning is this, that the tractor is four-wheel drive. In case of a four-wheel drive tractor, the weight distribution is kept 50 ratio 50 or 1 ratio 1. Okay. Means equal division is there. Why? Because all the four wheels of the tractor, they generate traction. Okay. In case of a two-wheel drive tractor, the weight distribution would be 60-40. Okay. 60 on the rear wheel, 40 on the front wheel. I am talking in percentage. Okay. Why? 10% more on the rear axle. Why so? Because when the static weight on the rear axle increases, then the tractive ability increases of that particular axle. So in my two-wheel drive tractor, the traction is being generated by the rear wheels only. That is why lugs are provided only on the rear wheels, and on the front wheels there would be no lugs in case of a two-wheel drive tractor. But in case of a four-wheel drive tractor, all the four wheels would be having lugs. Okay. So they all will generate traction. That is why 50 to 50 ratio 50 or equal distribution of the weight is there in case of a four-wheel drive tractor. While in case of a two-wheel drive tractor, it would be 60 ratio 40 in case no implement is attached. But when implement is attached, that ratio would be 80 ratio 20. Why? Because the weight, static weight, 20% of the trolley or any implement will also fall on the rear axle only, because the implement is attached through hitch system, which I already showed you in first question. So the ratio varies between 60 to 40 to 80 ratio 20. Okay. This is the thing in case of a two-wheel drive tractor. Now, is it clear to you? Understood or not? If any doubt is there, then please do tell me. I'll answer you once again. Okay. If it is clear, then please tell me it is clear. We will move forward. Okay. Yeah. Clear? Good. Very good. Clear. Good. Okay. Great. Now we will move forward. Okay. Great. The operation of 3-point hitch system, which provides better tractability, is known as free link operation, restrained link operation, traction link operation, none of the above. Okay. Do try to give your opinion. The operation of 3-point hitch system, which provides better tractability, is known as free link operation. Okay. Restrained link operation, traction link operation, or none of the above. Just to try to give your opinion. Okay. According to you, which will give more tractability?
Traction link operation.
Okay, traction link operation. Okay, great. I'll just write here. Great. Okay. Two people are saying C, traction link operation. One person is saying B. Okay, great. Anybody else? Yes, B. Good. 50-50. Tie is there. No tie is there. C is having majority. Good. Okay. Okay. I'll move forward. Okay. Yes. B. Good. Okay. I'll move forward. Okay. The correct option would be restrained link operation. Okay. See here. Three option I have given you. Traction link operation, it is not a standard term used in the context of three-point hitch system. There is no such operation which is known as traction link operation. Okay. No link is there which is known as traction link. Okay. Two types of links are there. I already told you. I showed you the tractor hitch system, and in that two possible operations are there: free link operation and restrained link operation. Okay, free link operation means in this mode the lower links of the 3-point hitch are allowed to move freely. That is first thing. Okay, so the traction generating ability would be somewhat less. But in restrained link operation, this mode involves restraining the movement of the lower links, which helps in transferring more weight from the implement to the tractor. That I already told you. From 60:40, it would be 80:20. Okay, thereby improving the tractive ability. Hence, the correct option would be restrained link operation. Okay, two particular operations are possible from 3-point hitch system. First one is free link operation, another one is the restrained link operation. In free link operation, the movement of the lower links is allowed. Okay, so the weight transfer would be somewhat less from the implement side to the tractor side. But in case of restrained link operation, the restraining movement is restricted of the lower links. So the weight transfer would be somewhat more in case of restrained link operation. Okay, understood? More about all these questions you will understand in your practical classes. Okay, not everything can be visualized so much clearly. I am trying to give you the practical picture as much as possible, but you will just try to go through these questions, but you will visualize them in field, then you can just be very sure about them. Okay, clear or any doubts? If you are clear, then tell me you are clear. If you are having any doubts, then please do tell me. Yes, Hari Krishna is saying clear. Yes, ELS Swami wants to ask something. Yes, please do tell me. Yes, please ask me, Yella Swami. Okay. Please do type in if you want to type. Yes. Abhishek Kumar says, what is the significance of restraint? Yes, I'm telling you. See, two modes of operations are there in case of our 3-point hitch system. Okay. First is free link operation. Another one is restrained link operation. Restrained link just means that I am restraining the movement using the chains. Okay. So the movement would be somewhat less. Okay. This is the only significance. When restraining is there, then the load transfer from the implement to the tractor would be somewhat large. Okay. So what will happen? More traction or more tractive ability will be generated. This is the only thing. Okay, not of much significance. Okay, this is the meaning of restrained link operation. Is it clear to you now? Okay, great. Okay, we shall move forward. If everything is clear to you, then we shall move forward. Okay. Yes. Yes, this particular question. Please do try to answer this. The ground wheel of a seed drill is an example of powered wheel, towed wheel, braked wheel, self-propelled wheel. Okay. Four different types of wheels are there. I'll talk to you about these wheels in great detail in the few upcoming slides, but just try to solve this. Ground wheel of a seed drill is an example of powered wheel, towed wheel, braked wheel, self-propelled wheel. Yes.
Powered wheel, sir.
Okay, okay, towed wheel. Okay. Okay, two people are saying towed wheel. Good. This is already taught it in great detail by the professor. Okay, before this session, please do try to revisit the content week wise. Okay, the professor has taught this in great detail, I think, in week two's content. Okay, it has been dealt, so please do try to revisit the content. I am just here to give you a summary as well as answer your doubts. Okay, but the textbook study cannot be replaced. Okay, the lectures are there for enhancing your knowledge holistically. Okay, so please go through them, okay, before this session, beforehand only. Okay, then it would be more fruitful. Okay, this is not a replacement, okay, to the theory lectures. Okay, this is just a practice session for you so that you can practice, you can ask doubts, or if you are having any queries, then you can ask me. Okay, yes. Pooja is somewhat silent today. I don't understood what is the reason. She has not given any opinion on any question. Why? Feeling bored or anything? Then please do tell me. I'll adjust something accordingly. In the previous lecture, you were very active. Today, you are not very active. Please try to be active. Yes. Four people have answered. No, no, five people have answered. Toad wheel. Okay. Then toad wheel. Then Abhishek is saying powered wheel. Good. Varnika is saying braked wheel. Okay, great. Then Mercy is saying B, toad wheel. Good. Yes, I am expecting some opinion from two more people. If they are interested enough, then they can tell me their opinion. No problem. Even if it is correct, no penalty is there. Please do try to be interactive. Okay. What is the humidity at your place? Any idea? If you can just tell me wherever you are, what is the humidity percentage with place? You have to tell me. I just want to get an idea. 85% in Moradabad, UP. Okay, good. I think there it must have rained in 2 3 days. That is why the humidity percentage is so high. Otherwise, it is below 50 only in UP region. I am from Uttarakhand. That is why I have an idea. UP border only, so I have got an idea. Visited UP more than Uttarakhand itself. Yes. Kanchipuram, Tamil Nadu, 47%. Good. Yes. Yeah. I understood this. 50% in Vellore, Tamil Nadu. Okay, good. If I tell you about Kharagpur, you will be somewhat astonished to listen to me. It is 95%. Okay. And it hasn't rained in, I think, 3 or 4 days. Small drizzling is there, but it hasn't rained much heavily. Still, it is 95%. I am sweating like hell. That is why I just wanted to have a conversation about it. Okay, no problem. The ground wheel of a seed drill, it is an example of braked wheel. It is an example of braked wheel. Okay, four types of wheel are there in this particular uh, question. Okay, I'll tell you about all the four types of wheel in great detail. First one was toed wheel. Okay, another one was driving wheel, another one was self propelled, and another one was braked wheel. Okay, in case of toed wheel, you just see toed wheel is a wheel which is having a load, but it is getting towed like a front wheels of the tractor. Okay, front wheels of the tractor are loaded and they are not able to generate any amount of traction. So there they have to be towed, they have to be dragged. Okay, so towing force that acts on that particular type of wheel. Okay, in case of a towed wheel, the traction, okay, or the torque, okay, that would be equal to zero. Example is front wheel of a tractor. Okay, just try to visualize in this particular figure a side of towed wheel. Okay, forget about the ground reaction, I'll tell you about that in next few slides, just bear with me. Okay, another one is driving wheel. Driving wheel, it is having both torque as well as pull. Okay, it is driving wheel like the rear wheel of a tractor. It is able to generate the torque also, as well as it is able to generate pull also. Okay, H is pull, T is torque, W is weight, G is ground reaction. Okay, what is the direction of ground reaction, why is it changing, I'll just tell you, bear with me. Okay, in this particular slide I am giving you examples and giving you the basic idea, I'll tell you it in great detail. Yes, another one is self-propelled wheel. Okay, self-propelled wheel, it is in the transition, okay, between driven and driving force state. Okay, it is self-propelled wheel. Okay, pull is zero in this case. Okay, no pull is acting. Still, due to the applied torque, it is able to overcome the motion resistance or the friction from the soil. That is why it is known as self-propelled wheel. Another one was braked wheel, the wheel which is having negative torque. Okay, the wheel which is having negative torque, that is known as braked wheel, like the ground wheel of our seed drill. It is having negative torque. Okay, why is it having negative torque? What is negative torque? What is positive torque? Okay, just I'll tell you. Okay, if I'll take the example of rear wheels of a two-wheel drive tractor. Here I am talking about the two-wheel drive tractor. So rear wheels of the two-wheel drive tractor will always have a positive torque. They have to be able to generate torque, positive torque, in order to propel in the forward direction. But in case of a ground wheel of a seed drill, meaning is there, it provides an outward thrust while it is getting towed, or while it is getting carried, it tries to push the tractor in certain forward direction. That is why it is known as braked wheel, or the wheel which is having negative torque. Okay, try to visualize this when you will see the operation of the seed drill in field in your practical classes, then immediately you can remember this fact. Okay, regarding ground reaction, why some ground reaction is there in this direction, that direction, I'll just tell you. Okay, bear with me just a second. Yes, in case of my powered wheel, first of all I am talking about the powered wheel. Okay, situation is this: the wheel is driven by an engine or a motor, that is my powered wheel. Okay, forces which are getting applied, the driving force is applied at the axle, causing the wheel to rotate. Okay, ground exerts a forward frictional force on the tire to prevent slipping. Okay, that is why, according to Newton's third law, the reaction from the ground would be in this direction, which I have shown in the figure. Okay, but in case of towed wheel, the thing is that it is getting pulled by another force. Okay, so the towing force pulls the wheel while the ground provides a forward frictional force just to prevent it from slipping in the backward direction. That is why the direction of the ground reaction will get diverted, and it would be in such a manner which I have shown in the right hand side figure, according to Newton's law of action and reaction. Okay, while in case of my braked wheel, the direction will remain same. Okay, but in case of self-propelled wheel, since no frictional force is being offered, so just to counteract the force, which is counteract the weight which is coming onto the tire, the direction of the ground reaction would be in straight line. Okay, I know it is somewhat complicated. That is why in questions we just ask the examples. So do try to remember this particular examples like towed wheel, front wheel of a two-wheel drive tractor, then driving wheel, rear wheel of two-wheel drive tractor, then self-propelled wheel, transport wheel of power tiller, brake wheel is ground wheel of a seed drill. Okay. After the class gets over, just go through this PPT once more. Then you will have a wholesome idea what are four types of wheel, why ground reaction is getting changed. Everything is there in the slides, but I know that it is somewhat difficult to digest in the very first attempt. This particular course, if you want to continue in higher studies, you will get a full 6 months course for this particular thing, that is soil mechanics, intelligent traction. This particular course is there in MTech. Okay, in that particular course you would be taught this in great detail. Okay, understood something? Got any idea? Any confusion is there? Anything? If it is there, I suggest you then please do revisit, okay, these particular slides. Then you will have a wholesome idea. Okay, already sir has taught this in great detail in the lecture, so you can go through them also. Okay, clear? Can we move forward? If any doubt is there, then please do ask me, otherwise tell me. Clear? Okay, clear, good. It is clear, I am happy it is clear to you. Great. For the other people, I can understand this is somewhat tricky to understand. Okay, do revisit this. Everything I have written for you people. Okay, there is nothing. I have seen a lot of books, then I have written the clear cut explanation why things are happening like this. For the exam point of view, just try to remember the examples, but from the theoretical point of view, just try to revisit this. Okay, you will get a lot of understanding. Okay, yes, I shall move forward. Okay, because some numericals are there, so that will take more time. Okay, okay, good. Yes, already I have explained you each and everything. Yes, the center of resistance, this question for the day. The center of resistance of a MB plow lies at a distance equal to 1/4 the size of plow from shear wing, 1/2 the size of plow from shear wing, 3/4 the size of plow from shear wing, or the none of the above. This is a very interesting question. Generally, uh, the answer is given, but the clear cut explanation I'll provide you. Okay, today. Yes, Abhishek is saying C. Good, very good. Please do give your opinions. Free hand. Okay. Maybe it is correct, incorrect, but do participate. Okay. Yes. Three people have said it. C. 3/4 the size of plow from share wing. Good. Yes. Good. C. Good. Good.
Yeah, yes.
Okay. C. C or D. Whatever is your opinion, please do tell me. Yellow Swami, is it C, A, D? Anything? You were saying
No,
something?
sir. Yeah.
Okay, okay, okay. I'll just write.
Already
No
told.
problem. I'll write. Okay. Yes. Any more opinions? I think all people have given their opinion. But today Pooja is not active. I am not happy. Please do be somewhat active. Okay. I don't think so. It takes much of your effort if you have joined from mobile or laptop. You have to just type a keyword. Thereby, I get some idea that you people are listening to me. Okay. Had it been offline lecture, I will be judging from the faces of the people only. Like here, I take offline classes. Okay. But here on the online medium, I cannot see you. That is why I am asking you about your opinions. Okay. Do direct. Okay. Don't feel shy. There is nothing to be shy. Okay. Yes. The center of resistance of a MB plow will lie at a distance equal to 3/4 the size of plow from the shear wing. Okay. This is the answer. The center of the resistance of a MB plow is located at a specific distance from the shear wing. How we got it? I'll tell you. Bear with me. In great detail, I'll tell you about exact modeling process. Okay. Yes. The center of resistance is the point where the resultant force acts on the plow. Okay. Resultant force acts on the plow, balancing the forces and moments acting on it. Okay. That is the particular point, which is known as center of resistance. In the previous lecture, also somebody was asking what is the difference between center of resistance, line of pull, line of action. Okay. Line of resistance also. Okay. So here it is the clear cut explanation or clearly I have written what is center of resistance. Okay. So just see here, center of resistance is the point where the resultant force acts on the plow, balancing the forces and moments acting on it. This is the explanation. Okay. For a moldboard plow, it is generally considered around 3/4 the way from the shear wing to the end of the mold board. Okay, from the shear wing to the end of the mold board, you have to get the 3/4 of the distance. That would be my uh, center of resistance. This placement helps to ensure the plow operates efficiently and effectively while minimizing the draft force. Okay, somewhat balancing is required in the x, y, and z direction. That is why knowingly we have kept it at a 3/4 distance from the size of 3/4 the size of plow from the shear wing. Okay, why we have kept it, why we haven't kept it at 1/2 distance, why we haven't kept it at 2/3 distance, I'll just tell you it in great detail. Okay, let us move forward. Okay, see, here I am telling you somewhat here I am talking you about modeling. Okay, this particular thing might be of somewhat interest to you in your btech or in your mtech projects. You can try this. Okay, this particular modeling is known as finite element modeling. In my previous lecture also I told you some I gave you some basic idea about this, but in today's lecture I'll tell you this in great detail. Okay, see here we have modeled the entire moldboard plow. Okay, here we have modeled the frame components, bottom and standard, front view, rear view, side view, 3D model. Everything we have just modeled to the scale in our software. Our SolidWorks software is there, KTI is there, okay, ANSYS is there, Abacus is there. In all these softwares, we have modeled the implement first. First step is this only. Okay. After the modeling, here we have modeled the slices. Okay. See here, to form a particular curvature or a section. Okay, why the wing of the moldboard plow is of certain shape? This is the answer to that particular question. Okay, see here we have created the entire surface in the terms of finite pieces or finite surfaces of that particular uh, metal or material from which the entire surface is modeled. Okay, so finite number of pieces I have created or of that particular surface, and I have assembled those particular pieces. This is known as modeling of the surface. Okay. So moldboard curves I have generated, then I have generated the 3D curvature. Okay. Just for example, I am telling you if I am not able to understand. For example, a mouse is there. Okay. A simple keyboard or mouse which you are using during this class is there. A mouse is there. So I am taking a very thin slice of that particular mouse along y-axis. So if I'll take all the slices and join together, I'll be able to model that particular surface. This is the crux. Okay. Then another thing, here you can see after modeling, I have modeled the surface of that particular implement also. I model the entire implement also. Now I'll create a soil box or a soil bin that I showed you in first lecture. Okay. Try to revisit it or recall it. The entire soil bin I can model in my software. Okay. I'll provide the constraints at each and every step, at each and every point. Okay. So thereby I'll be able to model the entire soil box, and inside my soil box, virtual soil box, all this is happening in a virtual environment. Nothing is getting it in real time. Okay. So I'll be able to run this moldboard plow in this particular soil bin or virtual soil box. Certain kind of depth I can I would be able to maintain. Okay. And certain uh, parameters I can adjust. Okay. Like the center of resistance I can adjust, surface I can adjust. Okay. Depth I can adjust, force I can adjust. A lot of means constraints can be set here. This is done in a particular software which is known as EDM software. Okay. Altair EDM is the software. If you get time some day, then please do see it. Okay. How it is getting done. It is a very matlab complicated process. Okay. It's not so much simple to just put the constraint, but in KTS software it is very easy to do that. Okay. It is complicated, somewhat complicated. You can do it, but it will require you somewhat understanding of the mechanics, interaction between two solids. That is what you have to master first. After that, you can do it in EDM software, but in KTS software, it is very simple. You have to just provide start and end constraints. Okay. Then you can model the entire mold board like in the figure 5. Here I have done no experiment. I have only made it in virtual environment. Okay. No particular raw material wastage or anything is happening. Okay. So time is getting saved as well as my effort is also getting saved. Okay. So soil cutting process and involvement of tillage force components for the moldboard plow. Here I have obtained the draft force, the lateral force, the vertical force, the variation I have plotted with the surface. Okay. So similar to that, I'll get the von Mises stress. Okay. And the draft force also I'll be able to plot with the number of plow frame elements as well as with the soil cube elements also. Okay. So this was to just generate interest inside you. Okay. So here you can see in the virtual environment, I'll be able to predict where I should keep my center of resistance in order to provide maximum stability to my implement during the field operation. Okay. Clear? Clear? Not clear? Having any doubts? Then please do ask me. Otherwise, tell me. We'll move forward. Okay. Clear? Not clear? Feeling sleepy? Sir, source of research paper. I have already mentioned it. Okay. Just see it here. In reference, I have provided you what is the source of research paper. Some universities, they only purchase the subscription. So you can only download it if your university or your institution is having access to that particular, I think, publisher. Okay, that is restrained. That is why I always provide you the resource also as well the relevant information. I always put it in my PPT. providing reference also, as well as giving you the relevant information also. Okay. Yes, name of software, sir. First software which I told you is Altair EDM. I'll just write it. Okay, no problem. First is Altair. Altair is a company. Okay. Yes, and the second software is KTR V5, or I think V7 is the latest one. Please do read. Long ago, I used both of them, so right now I am not in touch. Okay, maybe 1 years before I used Altair EDM for my research. KTR V7 I applied during my BTech. Okay, both of the softwares you can get it. Okay, yes. Any more doubt? Anything you want? Any clarification? Anything? If nothing is there, then please do tell me it is clear. Then we'll move forward. Okay. Clear? Good. Good. Okay. 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 Clear. Okay. We shall move forward. Yes. Okay. After this hefty discussions, okay, two hefty discussions on question number fifth and sixth, we will solve one numerical. So you will get somewhat refreshed. A combination tillage implement having passive active tillage combination. Passive active tillage combination means, yes, Varnika, I've seen your question. I'll just answer it. Okay. Yes. Combination tillage implement having passive active tillage combination operated at a speed of 4 kilometer per hour experiences a total draft of 10 kilonewton. Okay. Torque is given to you. Okay. And peripheral speed is given to you. What is the power requirement by the prime mover? Okay. What is the meaning of passive active tillage combination? Passive implement is that which only exerts uh, draft. Okay, the tool is not powered, while in case of active tillage implement, the actual cutting element would be powered. For example, of passive tillage implement is cultivator, active tillage implement is rotavator. The actual tool which is cutting the soil has to be powered. That is the meaning of active tillage implement, while in case of passive tillage implement, it would be draft only which would be acting. Okay, so you have to separately calculate what is the power requirement of the active tillage implement, what is the power requirement of the passive tillage implement, then you have to sum it. Take 5 minutes time, but do try to solve this. Okay, when you will be solving this type of questions, then only you will be able to solve them in the examinations. Okay, yes, do try to take it is 16:03 in my watch. I'll contact you. I'll just ask you after 2 or 3 minutes. Okay. Yes. Do solve it. Yes. Now come to our question. Yeah. How can we create a soil with different characteristics in real life in a software, sir? Very good. It is very kind of you to ask this type of questions. It gives me hope that you are very interested, or you listen to me properly. Okay. I'm very happy that you asked such a wonderful question. Yes, now I'll answer it. Okay. See, in your if you would pursue some higher studies like in MTech or PhD, you will be taught a particular course which is soil mechanics and tillage interaction. There you would be taught a lot of properties about soil. For example, bulk density is there. Okay, one particular property is there, then cone index is there. Okay, then friction is there, then shear stress measurement is there. Okay, shear plate test is there. A lot of tests are there. After those tests we get the idea about the properties of different type of soils. Soil is a viscoelastic medium. Okay, so after getting the idea about the properties, those particular properties, how the implement and the soil is interacting with each other, we get different types of friction angles. Okay, as well as other properties are there which we get. The main property which we use while modeling is friction angle only. Okay, So when implement and soil is interacting, then three particular friction angles are there. One is between soil and implement. One is between the particles of the soil. Okay, and one is between the implement itself. Okay, so at the interaction, if we know the properties, okay, then what we do, we try to provide the constraints. Constraints are nothing but the preliminary conditions before solving a modeling problem. So inside the software, if I'll provide constraints, that what would be the maximum and minimum range between these particular properties can vary, as well as at which particular line of action, as well as at which particular point, what force is acting, then I would be able to model the entire interaction between the soil and the implement. Okay, regarding how I can model the soil, that is a very interesting thing. See, soil is a viscoelastic medium and the properties they change in the entire region. There, that is why the modeling of soil is somewhat difficult. But how do we do it in software? We try to model it in element wise. I told you modeling of any surface is also difficult, but how we do it? We try to make slices of it. Okay, if we know that how my property is varying between each and every slice of very small dimension, then I will be able to model the entire surface. Okay, so as a collection of macromolecules, we try to model our soil. Different types of techniques are there how to model soil. Okay, first one is that you see it as a macromolecule. Okay, then you provide the property. You say that my soil is composed of spheres, each having a volume of 4 by 3 pi r cube, and you create n number of spheres, and you try to fill a box inside it, and you say that this is my soil. Okay, first approach is this. A lot of research papers they generally tend to take this approach because this is easy. Another approach is regarding surface. Try to model the entire cube of soil as a surface which is having a cubic equation, and the property from the initial stage to the end stage would be varying in a cube manner. Okay, so that is another approach. Another approach you can develop, you can just when you come in the research field, then you can also approach. Two particular approaches are mainly dealt. Okay, both the approaches I have told you regarding the modeling of the soil. Okay, yes, any more doubts? Okay, great. Yes, we also have done I personally have done some work in my btech, but I was that was not that much scaled up. Okay, in my phd only I have done some more work on the simulation as well as modeling, so then my understanding is now wholesome how it has to be done. Okay, so if you are interested in higher studies, then please you can pursue it. Okay, it's a great topic, and for Indian soil conditions, I'm telling you, it has not been done fully. It is incomprehensible till yet. Okay, so if you will step up in this particular domain, you will be the pioneers. Okay, whatever you will be doing, it would be taken as some benchmark. Then work would be stacked upon it. Okay, for Indian soil conditions as well as for Indian agriculture, these advanced approaches haven't been developed. Okay. So if you are doing some PhD project or you are doing some MTech project, you can please pursue it. Okay. Yes. Only thing is this it requires a high-end PC. Okay. That's it. With at least 8 GB or 16 GB RAM. Okay. Only thing is that. Yes. Yeah, we got diverted from the topic. A question is there. Please do solve it. Nobody has solved it yet. I was telling a different story. Maybe you got distracted. Okay. Now focus on the question. Okay. Yeah, answer is B. Good, very good. 16.14 kilowatt. Good. You have solved it. Very nice. Other people also, please do try to solve it. Okay. If you are getting some another value, Sir, can you give the formula? Two formula are there. For power consumption, if torque and RPM is given, then the formula is P equal to 2 pi n divided by 60. Okay. And another formula is F into V. This you must have read in your 11th standard, I think. In 11th and 12th standard, this is dealt. Okay. Two formula are there. In both the formula, you have to use SI units. For calculating the power consumption of a passive tillage implement, you can use F into V. Okay, directly. Draft is given, speed is given. And for getting the power consumption of an active tillage implement, you can use P equal to 2 pi n divided by 60. Maybe if you are having RPM in place of RPM, if you are using RPS, then you can eliminate this 60 in the denominator. Directly you can write 2 pi T into n. Okay. Yes. Now solve it. Tell me the answer. If you are getting some another answer, you can always type in the comment box. Okay, no problem. For numerical, from now onwards, if you are getting any another answer, then also you can just tell me. Okay, that I am getting this much answer. I'll also correct if I am wrong. Okay, no issues there. Do try to solve it. Only one person has given the answer. Please do solve it. Okay. Okay. I'll show you the solution. Okay. Yes. The correct option would be this one, 16.14 kilowatt. Abhishek has correctly answered it. Okay. As I already told you the approach, power requirement for passive implement. First of all, this I have to calculate. Okay. Yes, it would be F into V. 16.126. Great. You are getting it correctly. It is nearly around 16.14. Good. First formula I will apply F into V. Here you see draft force is given in kilonewtons. Okay. So I'll convert it into Newton by multiplying it by 10 raised to power 3. Okay. So draft force I got it as 10,000 newtons. Then speed is given in 4 kilometers per hour. What is the SI unit? Meter per second. Multiplied by 5 by 18. Got it? So I'll get 1.11 meter per second. Then directly calculating the draft power requirement, I'll be getting it as F into V. What is the value which I have got? 11.11 kilowatt. Okay, just check it once. If some mistake is there, see here in front of you also, I am also doing it once more. I have done it previously also, and I am doing once more also, just for showing you. Okay, so first I got the draft requirement. Okay, power requirement which is pertaining to my draft. Okay, for passive tillage implement, I got as 11.11 kilowatt. Next, I'll try to calculate the power required for the active implement. It will be given by formula 2 pi nt into nt divided by 60, or T into omega. Omega is nothing but 2 pi n divided by 60. Okay. Or if you want, you say n in RPS, then it would be 2 pi n. Okay. So I got value as 2 pi nt divided by 60. Now T is given as 200. N is given as 240 RPM. So by 60 I have to do, because the SI unit would be per second. Okay. So directly everything is in our SI unit. So I'll just keep it 2 multiplied by pi. Okay. Multiplied by n, which is 240, multiplied by uh, t, which is 200, divided by 60. What I got? 5026.548. Okay, this value I got. Okay, yes, you would be able to see it. I have written it here also. Okay, 5026.548. Okay, this value I got, which is approximately 5.03 kilowatt. Okay, now I'll sum 11.11 plus 5.03. What is the answer? 16.14. Okay, got it? Any doubt? Anybody? If you are having any doubt, then please do tell me. I'll explain you once more. Okay. Or if some question is there, then I'll answer that particular question. Okay. Yes. Understood? Will you be able to do this in the examination? Confident? Not confident? Feeling sleepy? Clear? Can we move forward? What happened? I am teaching and your energy is down. Yes, sir. Okay. Yes, sir. I think you want to say yes, sir. Okay. Good. I am teaching, but your energy is down. You are feeling shy in typing. Why? Do type it. Okay. Can we move forward? What happened? Okay. Good. We'll move forward. Okay. Another numerical question. Okay. Don't feel sleepy. Numericals are good for your understanding. Great for your understanding. Do try to solve them. Okay. In a two-wheel drive tractor, static weight distribution on the front end, rear axle is 30% and 70%. Total weight of the tractor is 16.5 kilonewton. Wheelbase is 2250 millimeters. Then the center of gravity of the tractor from the rear axle is situated at this much meters. Okay. Try to solve it. Then I'll tell you the solution. First, you just try to come up with a answer. Okay. See, remember in this type of question, I am asking the CG from rear axle. Sometimes the options are set in such a way. One would be from forward, another one would be from backward. Okay. So just to confuse you, particularly in gate examination, this is very common. Okay. Here also, I'll just check and then tell you the probability. Yes, answer is B. Good. You have solved it. Very nice. Good. Rest of the people, please do try to solve it. Okay. Take 5 minutes time. No problem. I will wait. Let's try to solve it. Okay, then I'll tell you what is the solution. Okay. Yes. Okay. Varnika also got his at B. Good. Very good. Whomsoever are solving, they'll be able to solve these type of questions in the examination also. Yes. Hari Krishna also got B. Good. Very good. Okay. Good. Mercy also got B. Good. Very good. Just simple balancing is there. I think now I can just tell you how to solve it. Okay. Yes. It would be B only. You all got it right. Great. Yes. To find the CG of the director from the rear axle, I'll use weight distribution method. Okay. Here, just see in the middle arrow, I have pointed out. Okay. I have tried to draw the FBD in the right hand side. Okay. 16500 Newton force is acting at the CG. Okay. The wheelbase is 2.25 meters. Okay. And what information is given? 30 to 70 weight distribution is given. Okay. So 30% of 16500 would be acting on the front, 70% would be in the rear. Both the values I have calculated. Wheelbase already it is given as 2.25 meters. I think yes, it is given. Yes. Now I am asked about this EG from the rear axle. I'll take their distance as x. Okay. The weight of any implement or any body would be acting only at its CG. Okay, that is already given as 16500 newtons. Okay, so just try to balance these movements. X into 1 uh, x into 16500 equal to 4950 multiplied by 2.25. Just balancing the weights. Okay, then I'll get the distance as 0.675 meters. Okay, is it clear? Is it clear or some doubt is there? Balancing the weights about the rear axle. X into 16500 equal to 4950 into 2.25. Just simple balancing of the movements is there. Okay, about the rear axle. Already you four people have solved. Okay, so I'm assuming it that it is clear to you. Okay. Yes, we'll move forward. Okay. Yes, another question related to free link operation. Okay, free link operation and restrained link operation are the two particular uh, operations of the tractor using the 3-point hitch linkage system. So in free link operation, implement depth is controlled by gauge wheel, tractor draft control system, 3-point hitch system, position control system. Okay, just try to solve this question and tell me what is the correct option. Yes, Varnika is saying a good, very good. Yes, except Varnika. Any more opinions? Free link operation and restrained link operation are the two operations which are possible uh, using the tractor 3-point hitch system. Okay. So in free link operation, implement depth is controlled by gauge wheel, tractor draft control system, tractor 3-point hitch system, tractor position control system. Which system? Okay. 4 people have answered it. A, D, and then B. Okay, good. Yes. I'll move forward. Okay. In the free link operation, the implement depth is controlled by gauge wheel. Okay. I'll just show you what is a gauge wheel. In case of a mold board plow, you can see here jointer. I already explained you in my previous lecture. Coulter I explained you. Third figure is gauge wheel. It's an auxiliary wheel of an implement which helps to maintain uniformity in respect of depth of plowing in different soil conditions and is usually placed in hanging position. This particular thing which is here, just I'll mark it. This particular field is regarding my gauge wheel. Okay, just a second. In free link operation, the implement depth is typically controlled by my gauge wheel. It's a wheel which is attached to the implement like a plow or a cultivator and runs along the ground, and it helps to maintain a consistent depth of implement by adjusting its position relative to the ground. Okay. During the operation of that moldboard plow, you will be able to see it how it is just keeping the position of the implement in place. Okay, and maintaining the depth also. Draft control system. Okay, it is uh, used to adjust the load which is coming on the tractor. That is the functionality of draft control system. More on this in tractor system design course. Okay. Tractor 3-point hitch system. Okay, you already know what is it used for. It is used for lifting the implement, lowering the implement. Okay, but in free link operation, depth control cannot be directly done by 3-point hitch system. Tractor position control system. The system controls the position of the implement relative to the tractor, does not directly control the depth. Okay. Position control system, draft control system, they both will be dealt in great detail in tractor system design. Okay. Right option would be this one, gauge wheel only. Okay. Clear? Can we move forward? Or some doubt is there? Clear? Good. Great. We shall move forward. Okay. Yes. In clay soil conditions, traction on the pad wheels of the tractor can be increased by adding dead weights, decreasing surface area of the soil of the wheels, ballasting of wheels, increasing surface area of wheels. I have to increase the traction. What I have to do in case of clay soil condition? Three soil conditions are there: silt, clay, loam. Okay, three particular soil conditions are there. Okay, sandy, then clay, or loam. Okay, sandy, silty, somewhat same. Okay, sandy, clay, and loam. Okay, what is your opinion about it? How traction can be increased? Yes, B. Good. Decreasing surface area of wheels. Okay, good. Hari Krishnan, just to give you an idea, think about this problem. You are riding a bicycle, okay, and your wheel got stuck in the mud. Mud is generally clay. More part is clay only. Okay, it floats to the top. Okay, soil condition is it is just like that of paddy fields. Okay, and you are riding a bicycle. Okay, and your bicycle got stuck in the muddy condition. Okay, not just for irrigation, for everyone. Now what will you do? You will deflate your tire, you will inflate your tire. Just try to think in that manner. Will you increase the surface area, or will you decrease the surface area to get out of it? What you will do? You will increase the inflation pressure, or you will decrease the deflation pressure? Just think in that manner. Okay, practically also you can just understand. Okay, not everything you need to learn only. Yeah, good, now you got it correctly, because you must be having the experience of riding bicycle. That is why I told you the this particular example. Yes, the correct option would be D only. Why? See, other options you see adding dead weight on the wheels. Okay, as well. Okay, when I'll add dead weight on the wheel, what would be there? My sinkage will increase. Okay, because I have added some more weight on on the powered wheel. So, in case of clay soil condition, the strength of the upper layer of the soil is not that much high. So, sinkage will be there. So, traction will not enhance; it will decrease further. Decreasing the surface of area of the wheel. What I'll do, I'll just try to increase the inflation pressure. In that case, also the interaction between the soil and wheel will decrease. That is why my traction will also increase. The frictional force will decrease, and as a reaction to it, my traction will further decrease. Yes, ballasting can be an option, but two types of ballasting are there. One is by increasing the surface area of the wheels. That would be appropriate in case of clay soil conditions, because sinkage would not be there. Okay, but in case I go for adding the dead weights, because two types of things are done in ballasting. First is approach is increasing the dead weight on the wheels, other or increasing the surface area of the wheels. So increasing surface area would increase the traction, but adding dead weight on the wheels will not increase the traction. So my option would be this one, increasing surface area of wheels. Okay. Here, just for your reference only, I have given you this table. In this particular table, you can see in this column, clay soil is there, heavy clay is there. Okay. In this particular column, you can just see. Okay. Heavy clay is there. So, why, by using what option, I get what percentage of increment in the traction that I have given you, just for your information. Okay. It is not directly related with this question only. Okay. Yes. Similarly, here I have given you the relative improvement in traction performance in case of particular types of wheel conditions are there: large, dual, and solution field. Okay. Solution field means I have used 60 ratio 40 air is to water. That is the meaning of solution filled tires. Okay. Or sometimes we go for some heavier liquid like mercury water also. Generally, we don't use in case of our agricultural feeds, because it might get poisonous. Okay. But in case of snowy conditions, we go for heavier liquids also, deuterium water, or mercury water. These type of waters also we can use. Okay, for increasing the traction. Okay, got it? Any doubts? Anybody? Got it? Shall we move forward? Okay. Okay, we will move forward. Okay. 10 questions based on the previous week's content I have dealt. Yes. Two particular doubts were there in my previous lecture. One was regarding that, ki, sir, show us what is dead furrow, what is back furrow. Another one was regarding line of pull, line of action. Now I'll take those doubts and I'll tell you it in great detail. Okay. Just see this picture. Okay. A disc plow is moving in forward direction. Okay. From the middle of the field, it is moving in the forward direction. Okay. This particular line, which is the implement is making, is known as headline in the center of the field. Okay. Now, in the second picture, the as I told you in my previous lecture, the operation, field operation, the implement will come again by reversing. Tractor will reverse, then the implement will be pulled. Okay. So, if you see in this particular picture here, this is my tilled soil. This one is also my tilled soil, but this one is my unplowed soil. Okay. Why is it unplowed? Because layer over layer it got deposited. It was never tilled. So this particular soil, if you will see during field operation, this one is known as back furrow. Okay, until land or the soil on which the implement was not able to overturn, it just overturned the soil, but it was not tilled. That particular row is known as back furrow. Okay. Another thing here you can see what is furrow wall. Okay, what is furrow? The implement was moving, the disc plow was moving, so central part is known as the entire part. Okay, in section. Okay, v sometimes v section, sometimes trapezoidal section, sometimes in case of cultivator it would be rectangular cross section. That whole cross section is known as furrow, and the side wall is known as furrow wall. Okay, at the edges of the field. Okay, when our implement would be moving at the around the corners or the edges of the field. Okay, the implement will throw the soil in our field side only. Okay, it will not throw the soil in somebody else's field. Okay, that is not the cultural practice. Okay, so at the edges of the field, the a furrow would be made which cannot be filled. It is always divide of the soil. During field operations only you can see it. Okay, that particular uh, furrow is known as dead furrow, which is divide of the soil because it never got filled. That is why at the edges it is formed and it is known as dead furrow. Okay, understood? Difference between dead furrow, back furrow. Clear? But in case of reversible plow, both will be eliminated. Okay. Because the entire implement will get reversed. Okay. Try to visualize it. Go to YouTube, see some videos of the reversible plow, then you will be able to visualize it very clearly. Otherwise, in your, I think in your practical classes, you will be taught how this both the furrows are eliminated in case of reversible moldboard plow. Okay. Clear what is dead furrow, what is back furrow? Yes, no. Shall we move forward? Clear? Good. Yes, I was expecting response from you only, Abhishek, because you asked in the previous weak. Okay. Yes. Another thing, another doubt was there regarding line of pull, point of resistance, virtual hit point, everything. So I have made a slide and I will tell you each and everything so that your all doubts are cleared. Okay. See, an implement is attached to a tractor. Okay. So just see in this particular figure here at the CG, the entire weight of the implement is acting. Okay. So pull is of an implement is the total force which is exerted upon the implement by the power unit. When the tractor will try to pull an implement, okay, it will try to pull in the forward direction. So the force which would be acting from the implement side onto the tractor, that would be known as pull. And the horizontal component of pull is known as draft. Specific draft is nothing but the draft per unit area. Side draft is the component of the pull which is perpendicular to the line of motion. Okay. So first four points are clear. After that, power. Power is nothing but rate of doing work. Okay. Work done per unit time is known as power. Drawbar power. What is drawbar power? In relation to either a pull type or a mounted implement, it is the power which is actually required to pull the implement at a uniform speed. Okay. Drawbar power is nothing but draft into speed. Okay. In center of resistance, what is center of resistance? It is the point at which the resultant of all the horizontal and vertical forces, including the parasitic forces, okay, they would be acting at certain point that would be known as center of resistance. Here I've shown it through a red dot. That is my center of resistance or point of resistance. And what is line of pull? Line of pull is nothing but an imaginary straight line which passes from the center of resistance and and we extend it towards the center of pull. That is my line of pull. All the definitions I have written here also, I have shown you a visual picture also so that your understanding about these particular concepts is rock solid. Okay, great. Understood? These two doubts were there in the previous lecture. Not able to visualize back furrow, dead furrow, not able to visualize center of pull and line of pull. One person asked and she left. I don't know what is the reason. Yes. If it is clear to you, very nice. Thank you. Okay. This is the end of my this particular session. Okay. If you are having any more doubts, then I'll be here for 5 more minutes. Thank you for joining. Do join the session next week also. Okay. And if you are clear, then you can kindly leave. The session is over from my side. It is open for discussion. Okay. Yes. Please do ask me. Yes. Yes. One question: what is parasitic force? Very good. Two terms I have just told you. One is horizontal force. One is vertical force. Another one was parasitic force. Okay. See what is happening. That when we try to pull and implement, in case we are trying to pull a moldboard plow which is attached to a uh, tractor, then pull would be required. Okay, that would be having two particular components, horizontal, vertical. Okay, so pull is there. Very understood this point. Okay, now some force we are applying onto the soil in order to pull the implement out of the soil. So, in response to our force, some force would be applied by the soil towards us also, towards the implement side also. That force is known as parasitic force. It is always subtracted. Okay. I am hopeful that in the theory classes, these particular concept would be told to you in great detail. We go for our three-dimensional analysis of the forces in case of tractor and in case of soil implement interaction. then this particular concept of parasitic forces comes into picture. For the time being, just remember it is the force, it is the reaction force which the soil applies on the implement. Okay, clear? Okay, good. Any more doubts? Anybody? Any discussion? Any debate? Clear? Good. Very nice. Any more discussion you want to do on any other topic? You want to have an advice about your career, that also you can just ask me. If you are not having any query, then you can please leave. Okay. Do join this session at the same time. Yeah. Sir, what is the syllabus? Sir, I want syllabus. Syllabus is everything which is in our weekly content. Okay. Everything which is covered by our professor, as well as everything which is covered in this lab interactive session, that is the only syllabus. Okay. If you want an outline, you can just go for the uh, heading of the particular lectures. Okay, that will give you a outline. Okay, but this is a, I think, 12-week course. So whatever will be dealt in our 12 weeks, that will be entirely in the syllabus. Okay, it's an NPTEL course. It is not a regular semester course. I understood that you want a wholesome outline. Okay, I think you would be getting it in online. Okay, online, the platform on which you visit, enter your details, then you get lectures in the same platform. You can get it. Otherwise, you can contact the NPTEL team also. They will be able to help you out. Okay. Yes. If the implement moves on a hilly area, is there is change in the line of pull? Yes, of course. If the implement is moving on a hilly area, first of all, in case of hilly areas, we don't go for tractor tillage till yet. Why? Because a slope is there. We are not already, the load is there on the tractor. Okay, so if slope would be there, then traction generation is somewhat difficult. So first of all, till the technology which is present in this particular era, we are not able to achieve this. And for your curiosity, if you are asking me that in case of hilly area, yeah, definitely change in the line of pull would be there, because the component of the weight will also be added to our horizontal component of force. That is why change in the line of pull would be there. Okay. I think in place of hilly area, you can say it that in case of tillage in a sloped area, will the change in line of pull would be there? That would be somewhat more appropriate question according to me. Okay. 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 Good. Good. Okay, guys. I'm ending the session for you all. Okay. Do join me next week. Okay. At the same time. Thank you all.